This work introduced a method for closed-loop orientation control of spherical parallel manipulators with revolute joints based on online convex optimization. The experimental setup used to test the validity of our approach is a 3D printed prototype of a 3 degrees of freedom spherical parallel manipulator with base and top mobile platforms connected by 3 legs. The manipulator base joints are actuated by 3 servomotors with internal PID position control. An IMU orientation sensor is mounted on the manipulator base platform. Actuators and the IMU sensor are connected to a control PC. The goal of orientation control is to compute online, via inverse kinematics, the position references for the spherical parallel manipulator actuated joints, in order to follow an external orientation reference. 2 different experimental scenarios are considered. At first, the inertial stabilization of the robot is demonstrated. The top mobile platform is maintained at a horizontal position, while the manipulator base platform is rotated arbitrarily. During stabilization, the manipulator spatial orientation is obtained from an IMU orientation sensor, mounted on the robot base. In certain cases, the direct use of inverse kinematic solutions can lead to link collision and singularity configurations of the robot. In the proposed control framework, the vector of joint references for the robot actuators, represented by a green dot in the right side of the screen, is defined within a predefined convex set, which excludes self-collision scenarios and singular configurations. The joint reference vector is computed as the closest point to the given external robot orientation reference by solving a quadratic program in real time, with a sampling time of 24 milliseconds. Thus, the manipulator always stays inside of its workspace. In the second scenario, we demonstrate the tracking of an external orientation reference signal generated using a game joystick. The top platform follows the joystick's orientation, and the same set of constraints on the workspace is enforced as in case 1. When a reference from joystick is fixed at a certain orientation, the top platform is always directed to that reference, while the manipulator base platform is rotated arbitrarily. This scenario fits into the proposed control framework, and the joint reference vector is computed depending on both the external reference and the orientation of the manipulator base platform. For more information, please visit www.alaris.kz.